And then we get, what do we get when we do that? 70. 70 and 1, you go to 71. Now from there, they say to do let's see, we have lots of operations here. So we divide it by 2, we're going to subtract 7. Okay, that one's going to be 64. And then we're going to divide by 8. That's 8. Then we're going to subtract 2. And then we're going to half that. Okay, so the last few were pretty straightforward. Okay, any questions on 30-second challenge? Good. Let's put it down on there. Stop sharing there. I'm going to go ahead and take attendance. Hold on one second while I do that. Today we're going to do thinking strategies. Again, some more fluency. We started some last time. Okay. So we'll start with some models. So you know that some models for subtraction, what they're called. I think you guys might have seen this a little bit already, but kind of to deepen our ideas. So I'm going to share my screen. Okay. This is Unit 2. Section 7. So we're starting out with subtraction models. And when we do modeling, we make drawings or we have some concrete models, but today we're just going to do drawings of the idea of subtraction, where it's like take away or finding the difference. And we don't, in our modeling, we don't want to draw operations. We don't want to draw like things like a minus sign or anything like that. We're going to depict everything and use arrows and like Xing out things to show that. Okay. So the first model is a set model. Set model is a group of objects. They're all individual. Okay. Subtraction models, we'll choose 15 subtract 7. Okay. We're really going to focus on the process. What does the process look like? We're not going to focus necessarily on the answer. Okay. So for set models and subtraction, you can show crossing out. So we can do 15 cookies, 7 eaten by your favorite character, whoever you want to be in the story, Cookie Monster or something like that. Okay, so there's 15 cookies there. And we're going to cross out 7. So you can show the subtraction by crossing out. Okay. Let's do a different color to distinguish them. 1, 2, 3, 4, 5, 6, 7. Okay, so I crossed out 7, and what we have is the number left right here. Okay, and when we want to know what number that is, we can go ahead and do counting is one way to do it. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so there's 8 left. Another way to do the set model and subtraction is, let's say that you have 15 marbles, and you throw 7 in a lake. No, I gave away 7. Sorry, that's a different example. Okay. And so that's a subtraction idea. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have 7 marbles here, or 15 marbles, and we gave away 7. We can show this by using kind of like a box around 7. So there's 1, 2, 3, 4, 5, 6, 7. I'm going to take this group of 7 here, and I'm going to use an arrow and show that it's just taken away. It's gone now from my set. Okay? And you can just count the number left, which is 8. Again. Another type of model is the comparison model. Okay, let's say that Jenny has 15 cookies. Her brother has 7 cookies. And how many more does she have? Okay, so this is a comparison. So we can draw 15 cookies. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And her brother has 7 cookies. 1, 2, 3, 4, 5, 6, 7. So when we're going to compare these, we need to draw a one-to-one correspondence between each set of cookies here. So those ones will correspond here, and we're matching these up to see how many are more. And so when we do that, we find the difference. And the difference again is 8, of course. Another type of model is a measurement or bar model. So we'll talk more about those at the end of the lesson. With subtraction, we've done these before in the homework. And let's say that Jenny spent $15 because we're modeling 15 minus 7. Her brother spent $7. How much more did Jenny spend? Okay, so the bar model, when we have a subtraction situation, there's going to be one quantity that's bigger than the other, or usually the first quantity is what I put down. So you're going to draw two bars for this one. One for the bigger quantity, one for the smaller quantity. So the bigger quantity, in this case, is Jenny's $15. So it's going to be I draw a long bar. Okay, and I label the bar at the top. Jenny's $15. Okay, that's how long that one is. And you can color that in if you want, whatever. So I'm gonna color it in a little bit. So there's Jenny's $15. And her brother has only $7, which spends only $7, which is less than what she does, less than half of what she does. So I'm gonna draw his bar about right here, less than half. You can color that one in. And this right here represents the brother's $7. Okay. The distance that's left, so the question is how much more did Jenny spend, can be found by this distance right here. Whatever the rest is, that's the question mark. Okay. So you put a question mark, that relates to the difference. Okay. One more model of subtraction is the number line. So how does subtraction look on the number line? Okay, so we'll draw our number line here. And draw a little bit lower. That's going to be 0. And 15 is going to be right here. Now what someone does when they subtract on the number line is that they start at 15 and they go back 7, okay, and you end up somewhere. Well, it's easy to start at 15, go back to 10, and then you'll go back 2 more, whatever number you end up with there. So when you go from 15 to 10, you subtract 5. Let me do this one in blue. Starting at 15, we're going to 10, and then we go back to 8, because that's what subtract 2 is. Okay. So both the 2 and the 5 are 7. 7 is the same as 5 plus 2. So it's okay to subtract 5 and then 2, because they are the same amount as 7. Okay. So those are pretty straightforward models. So pictures. All right, so now we're going to get into thinking strategies. Any questions on the models? Okay. For the addition, we're going to start with addition for thinking strategies just to review. And there are similar strategies for subtraction that we'll go over. So the first one to review is compensation. And for our addition problem, we're going to do 57 plus 38. Compensation with 57 plus 38. Now this one is the one where you will add and subtract from both numbers. And so I'm going to illustrate this vertically. Because I'm going to do that same thing for subtraction. Okay, so I'm going to add these two numbers, but I'm going to adjust the numbers before I add them to make them easier. Does anybody have any ideas of how I can adjust the numbers to make them easier?
You would do 60 and 40.
Okay, good. So let's go ahead and you're close. Let's go ahead and make the bottom one 40. So I'm going to add 2. And if I add 2 to the bottom number, I have to subtract 2 from the top number to make the sum the same. Okay, so you're going for easier numbers. So let's take a look at this one first. So we have 55. Better mark. That means 55 plus 40. You get 95. So that's making the bottom 40. You can also make the top 60, like was recommended. So we can do, or this one, 57 plus 38. Making the top 60 means I have to add 3 to this top number. And if I want to compensate, I have to subtract 3 from the bottom number to maintain the sum. And so when we do that, we get 60 plus 35, which makes 95. Okay, so notice that both of them end up with 95 with either strategy. Okay, so that's compensation. Strategy number 2 is called tens and ones. Okay, so whatever you call these, they might differ slightly between texts or lesson plans or whatever you guys come in contact with in the future. But the ideas are similar. And then there's probably even more than what I'm going to recommend here or go over here in the class. So we're thinking about 57 plus 38. Now tens and ones means that I'm going to add on 38 to 57 by tens first and then by ones next. So I need to break up my 38 into the tens and ones. 3 tens, 8 ones. So then when I add on my tens and ones, I have my 57, and I'm going to add on 30 first. And that's easy because all I have to worry about is the tens column and not the ones. That gives me 87. The 7 from the ones will come along to the right, and I'll take care of that now. Which means that 87 plus my ones, which was the 8, is equal to 95. So we got that one okay? Strategy number 3, breaking up. Breaking up with addition is a little bit different than breaking up with subtraction. So the idea is still we're going to separate one of the numbers into 2 numbers so that we can add them easier or subtract them easier. So breaking up means for this one, 57 plus 38 could be equal to, so let's to straight equal to. With this one, I'm going to break up kind of like what I did for compensation, where I'm going to break off the 2 from the 57 to add on to the 38. So 57 became 55 plus 2. Copy the 38. There's a property that I'm going to use to put my 2 with my 38 instead of with the 55. What property was that again?
Associative?
Right. I'm going to associate the 2 with the 38 instead of the 55. That's what I'm going to note here. Associative property. And that way I can get 55 plus 40. Okay, there's common themes, there's commonalities between these strategies as well. So some of them are similar to others. Strategy number 4 of 5. There's only 5 for addition. Partial sums. I can take my 57 and 38 and add them on, kind of like the algorithm, but not really. I'll show you how that one is. We're going to add the ones and then the tens, but I'm gonna just not worry about grouping or regrouping. So 7 plus 8 is 15. Okay. This one right here is 7 plus 8. This and this one right here is going to be 80 from the 50 and the 30. So adding the ones together, adding the tens together. 5 tens plus 3 tens. And then all I have to do is add the rest of it again by 5 and 1 is 9. Okay, so when I do that, I don't have to regroup anymore. Okay. That's partial sums. And what we're having, the last one is called expanded form, which you guys have seen before. I expand my 57 into the tens, 5 tens and 7 ones, plus 30 is 3 tens and 8 ones. Okay, so I group the tens together. Oops. $80 and 15 makes 95. Okay, so there's five strategies, thinking strategies for addition. On the homework, you'll have to go over some addition problems. And with all of these problems that have thinking strategies, just do 2, and I'll put this note in the homework assignment, just do 2 of the 5 or 6 thinking strategies. You pick whichever 2 you want to do, okay? So those are the thinking strategies for addition that we've done before. Let's go over to some new ones for thinking strategies for subtraction. Okay, and our example that we're going to use is 96 minus 58. So 96 subtract 58. Let's hear some ideas about how we can do this problem. Does anybody have any ideas that they've done before with subtraction, maybe, that they'd like to share about how to do this one?
I would break it up or do like the expanded form. So 90 minus 50 and 6 minus 8.
Excellent. Yeah, so we will go over that one for sure. Expanded form. That's number 6. That's will be the last one. And you mentioned breaking up, so that's number 4. So we'll break up the numbers into their place values, but then we'll also break them up more strategically so that we can do the difference. Okay, great. And
You could,
oh, go ahead.
I was just going to say you could do 2 to the 58 and 2 to the 96.
Okay, great. That one's called compensation. So you can add 2 to both of them. Compensation with subtraction is a little bit different than addition because it's opposite. So for addition, we thought of adding and subtracting the same number, but with subtraction, you have to add 2 of the same number or subtract 2 of the same number. I think we talked about that a little bit last time, so good. Okay, so yeah, now we're starting with some strategies. Was there another person that wanted to mention something?
I was just mentioning the same thing.
Okay, great. All right, so now that we're thinking about compensation, let's go ahead and do that. So we're thinking about compensation for 96 minus 58. And I do my compensation vertically. Just, it's a little bit easier for me, but you can do it horizontally if you would like. Okay, so I'm going to subtract them in this way, but I'm going to compensate. And when you compensate in subtraction, it's best to compensate on the second number, the subtrahend. So we're going to add 2 and add 2. You must do the same thing, okay? So a lot of people on the test will mix them up. But do the same for subtraction. You've got to maintain that same difference, like we mentioned last time. So my new problem is 98 minus 60. Okay. So a lot of times you can do this to avoid breaking up the tens into different ones and considering the ones together. Okay. We'll talk about that, I think, next class. We'll talk about the algorithm. But when we add 2 to both of the numbers, the minuend and the subtrahend, we can go ahead and subtract, and I don't have to do any regrouping. So 9 minus 6 is 3, and 8 minus 0 is 8. Okay, so we get 38 for our answer. Now I can't, if I try to compensate with the first number, the minuend, like we did with subtraction, by adding 4, I will still get something like, if I did 96 plus 4 and 58 plus 4, I will get 100 here, but then I still have to subtract 62, which is still regrouping here. So with subtraction, just think about changing the subtrahend, the second number, for compensation. Okay, number 2, counting up. We did this one last time a little bit. So for 96 minus 58, counting up. Does anybody remember how this one worked? How do I count up to find the difference?
You would count the difference starting at 58, like if you're doing it on a number line, and
Excellent.
then count the spaces between the 58 and the 96.
Okay, and we count them strategically to make it easier. What number would I add to 58, do you guys think, to help start counting up?
2.
2. So you add 2 to get up to 60. Okay, what other number? I'm going to 96 is my goal. So once you got to like 60, you kind of want to go for some 10s here to get there faster.
I would go to 90 next.
Yeah, go to 90 next. And the difference there is 30. From 90, go to 96. And all of these together are, you add them up, and then you'll find your difference. And that was 38. Any questions on counting up? Going to tens and ones. Okay, when you do tens and ones, you're kind of keeping a total in your head, just like with addition. So the 96 minus 58, I'm going to break up my 58 into tens and ones. 58 is equal to 50 plus 8. And now I'm going to add on the tens and then the ones. Or sorry, subtract off the tens and the ones, since we're subtracting. 96 minus 50 is equal to, so I'm just thinking about tens place when I can do this. So 90 minus 50 is the 40, but the 6 comes along for the ride. Then I do 46, subtract off the rest of the ones I need, which is 8 ones. And here you'll have to do a little bit of regrouping in your head, where you break up the 4 into like 3 and 1. Or what I do is I just say, okay, 46 minus 8 is 30 something, but I know that 16 minus 8 is 8. All right, so that's the tens and ones. Number 4 is breaking up. (96 minus 58). I'm going to set that equal to, okay, what they do with breaking up on subtraction is that they know that they have to subtract off 8 ones, but I only have 6 ones to do that with. So I'm going to break up my 96 into 80 plus 16. I do this so that I can take so yeah, and then I'm going to break up my 58 to 50 plus 8. So I break up my number a little bit differently so that I can do the 16 subtract 8 and not have to regroup. Okay? This is in contrast with expanded form, which I'll show you later. Okay. So we want to make sure we focus on those. And when we do that, we have 80 minus 50. Whoops. Let me go ahead and continue on here. When I subtract off this whole thing here, the 50 and the 8, I need to subtract off the 50 and subtract off the 8. So I'm kind of distributing the negative, or I'm subtracting off both those parts. And so be careful with that when if you do this strategy. So when I do this strategy, I go ahead and write 80 plus 16, subtract 50, subtract 8. Now what I'm going to do is I'm going to move the 50 over with the 80. And I can do that if I keep the sign in front. So this is key here. You can commute with subtraction if you keep the sign in front. So that whole thing. Otherwise, subtraction is not commutative if you leave that sign there. Okay, so I'm going to emphasize that with the blue. So you can commute. If sign is kept in front. Okay, so everybody got that okay? So 80 minus 50 is 30. 16 minus 8 is 8. Okay, that's breaking up. We're going to break up our first number, the minuend, so that we can subtract off that ones of the subtrahend. If you have multi-digit ones, that is. And even with like a single digit. All right. Is everybody excited? Look at all this knowledge that we're giving. Got this power now. I can just tell you guys are jumping for joy. Okay, we can subtract off parts without any algorithms just by taking away using partial differences. Okay, this is like partial sums. Okay, this is like partial sums, but we're going to subtract instead of add. And with the partial sums, remember we added the ones and we added without any grouping or carrying, and then we added the tens. So partial differences, let's see what you guys think about this one for 96 minus 58. I'm going to do this and maybe it's a good thing or not. We'll have you decide. Okay, and there's some students that have thought about this, so there's some book examples in different texts where they say, okay, 16 minus 8, or sorry, 6 minus 8 is negative 2. Does everybody agree with that? 90 minus 50, so that's my ones, and 90 minus 50 is 40. So if I add those together, I get 38, because 40 and negative 2 is 38. What do you guys think about that?
I think it works for like adults who know that you can go negative, but like I've tried this with my kids who are in first or second and third grade, and they don't really comprehend the negative numbers.
Yeah, they don't. They don't have any meaning for them. Like when we build with addition of regular numbers, we work with base 10 blocks, we work with chip models, we build the meaning. If you were to show them this and say, okay, 6 minus 8 is negative 2, they will lose all meaning for it and they won't really follow. Some students can follow, but that's like 1 in 100 or something. Very small percentage. So, question?
With them not understanding, like, would it be easier to show them like the partial difference with the negative 2 on the number line? Or would that be too?
Well, on the number line, you'll want to start with 96 and then go backwards from there. So it wouldn't really, the number line is a model that wouldn't really show up on the partial differences.
Oh,
So
okay.
just with the numbers.
Yeah, I was thinking starting at like the -2 into the 40 and then showing that there's 38 differences between there, but that would be like
Oh, I
like
see.
question.
Yeah, you'll have to get the 58 down to -2 and then the 96 down to 40 to show that difference. So it's a bit pretty big of a jump.
Yeah, so
But yeah, those are good thoughts. So
freaking
this is
big.
just something for you guys to like think about and do. Okay. So you might have some, well, you'll definitely have smart kids where they'll do crazy things and they might even get this, or maybe you can use this as a strategy to occupy your little smart kid while you're working with some other ones. Say, ask them like, can you do this and does it work and why or why not? So
What age group do kids normally start to understand the negatives?
Oh, they don't teach negatives until middle school or junior high, 6th grade. So the students will understand, a lot of students will understand them or know what they're about before then, but we don't formally do the concrete and pictorial work until 6th grade. So yeah, it's important to understand fractions and stuff better first, build that understanding. Okay, last strategy is expanded form. An expanded form follows the partial differences. Expanded form, again, is breaking the numbers up into place value and then just operating on from there. With breaking up number 4, we were able to be more strategic so we can avoid going into negatives. But expanded form is like partial differences where it will go into negatives. But yeah, so there's other things like compensation, counting up tens and ones. Those first 3 are the ones that are easier to do and are more strategic for doing mental math, thinking strategies. These last 3 are just for fun. So, because we like to do fun things in math like this, right? So we have 96 minus 58 is equal to 90 plus 6. Subtract 50 plus 8. And we have our 90 plus 6, subtract 50, subtract 8, because I'm subtracting both those. I need to try and subtract both of them at the same time. In order to do that, we have to subtract them by parts. Okay, so that's why it works out that way. And we have 90 minus 50 plus 6 minus 8. So here's the 40. And then instead of saying -2, I'm just say subtract 2, because subtraction and negatives are the same thing. You get 38. Okay. Let's see. We have 2 more minutes. I'm going to do another example. I want you guys to choose your favorite strategy for this one and just practice it on your notebook. Oops. And we'll have a couple people share out. We don't have much time left from our lesson. Let's do thinking strategies for 271. Subtract 133. Okay. So you pick your favorite thinking strategy. And I want to encourage some people who don't usually share to share out on these ones. Share it on this one. If what I post every lesson is my lesson plan notes, and so I will have all of them, all the thinking strategies worked out for this problem, but we won't go over it in class. So you can refer back to those for some extra ideas as you do homework. Some people, as you guys are working, some people are kind of big proponents of finding one way to do arithmetic or anything in school math and then sticking with that. And so what I showed you was like 6 different ways to subtract the same numbers. And so it's important as a teacher that you start learning other ways. you'll probably gain more of solidifying this knowledge as you are teaching itself, and you can see students use these ways and have some gravitate to others. But so give yourself some patience. I'm just throwing a bunch at you right now. So hopefully you can kind of stick with a couple of these so you can use them on the test. But then again, with the tests in this class, you have access to all these notes anyway. So just be patient as you learn different ways to add and subtract the same numbers.
I have a question on the 96 minus 58.
Yeah.
So I did it like, I broke it down like 6 minus 8 equals 2, and then like added, and then kept going, and then minus the 2 and the 4, and then got the same answer. But I thought that one was tens and ones. Like, which one would that be called?
Okay.
So like the 6 minus 8, and then the 90 minus 50.
Yeah, I don't know if that's it's a strategy, but I don't know if it's specifically one of the ones that we looked at.
Okay.
And so I don't think it has a kind of a more formal label, but it would
Okay.
still work.
Okay.
Yeah. So does anybody want to share out a strategy that they use to do this one?
I grouped mine like the last example that we had. So I did 200 plus 71 minus 100 plus 33. And then I did 200 minus 100 plus 71 minus 33. And I got 138.
Okay, great. That sounds like a little bit like the breaking up. So you broke up the numbers in a strategic way instead of just by place value. Okay, great. Anybody have one more? We'll have one more share out.
I did the partial sum or partial differences. And I did 271 minus 133, and 1 minus 3 is -2, and then 70 minus 30 is 40.
Good.
And then 200 minus 100 is 100. And then I added the -2 and the 40 to make 38, and then brought the 100 so I could get 138. And then another way I did it was I did 100 plus 40 is 140 minus 2 is 138.
Okay, great. So after the thinking strategies, go ahead and share again. Okay, so see lesson plan for all of these. After thinking strategies, we went to, okay, there's a couple of topics that are, let's see. Think of thinking strategies for subtracting mixed numbers. Okay, so we're going to go back to our fractions, and then we'll subtract with those. Okay. So our example is 8 1/5 subtract 5 4/5. For when you're subtracting fractions, you want to find a common denominator. So I've already begun with the common denominator. And so first thing is find common denominator if they're not common. And I think we'll talk about that more next time as well. When I want to subtract these, so in the homework for the book, they're already going to be like this. If I want to subtract these, the first way is to think about compensation. It's a good way to change the numbers to make them easier to subtract. And I do my compensation vertically, but you can also do this horizontally if you want. 8 1/5 subtract 5 4/5. So when I'm going to subtract these two numbers, I'm going to compensate the bottom number, the subtrahend, to a nice round number, and then it'll be easy to subtract without any regrouping or pulling from the 8. So what can I add here? To get up to the next whole number, I will add 1/5. With subtraction, you also have to add 1/5 to the top number. And we will have a new problem that will give us the same difference. 8 2/5 subtract off 6. And notice how that subtraction is easier, it's just 2 2/5. The second way to subtract this is with regrouping. So we have 8 1/5, subtract 5 4/5. I can subtract off the whole numbers and the fractions separately if I do regrouping, because as is, I can subtract off the 8 and the 5, but I can't subtract 4/5 from 1/5. So I need to regroup. I'm going to take from my 8. I'm going to take that out, and I'm going to add on, make that a 7 5/5. So I can change out one of my whole numbers with 5/5. And so I have 7 wholes and 5/5 plus another 5th. Now when I put them together, I have 7 6/5 minus 5 4/5. Now I can go ahead and subtract the fractions and subtract the whole numbers. So let's subtract the whole numbers to get 2, and 6 minus 4 is 2. So my answer is 2 2/5. So there's thinking strategies for subtracting fractions, or those mixed numbers where you can just do regrouping. At the end of the homework, they have comparing fractions again. We're going to compare them in the sense of subtracting fractions. So there's a few problems about whether or not the sum or difference of fractions is greater than or less than 1, without doing any algorithms, because we don't know them yet for adding and subtracting fractions. So this is called greater than or less than 1. Our first example is 5/8 plus 3/7. Without adding them together using the algorithm, will this sum be greater than or less than 1, and why? So let's see what the difference is. I'll do this example and you guys can, try the next one. So we can see the difference between 5/8 and 3/8, or 5/8 and 1. So we need to use reasoning to help us here. So 1 is 4/8 from 5/8. No, sorry, 3/8. Let me add. Let me start that one over. 5/8 is 3/8 from 1. Okay, so all I have to do from 5/8 to get to 1 is to add 3/8. Here I'm adding 3/7. Okay, so we need to compare 3/7 and 3/8. So once we do that, we compare. Three-eighths with 3/7. Because we can compare those two, we can know if the sum will be greater than or less than 1. Is 3/7 big enough to put the sum over 1, or is it not big enough to put the sum over 1? What do you guys think?
Will you ask that again?
So I'm adding 5/8 and 3/7 together, right? 5/8, 3/7. I need to see if that sum will be greater than 1.
Yes.
Okay. So what I need is to know if 3/7 and 3/8, how they compare, because if I add 3/8 to 5/8, I get exactly 1. So I'm going to compare 3/8 to 3/7. Now, if 3/7 is bigger than 3/8, then my sum will be bigger than 1. If 3/7 is less than 3/8, my sum will be less than 1. I heard a yes.
They will be bigger
Why?
because this 1/7 is bigger in size than 1/8. And if you have 3 of each of those, then you're gonna have more because each one of those 7 is bigger than each one of the 8s.
Right. So this is a comparison of common numerators like we had last time. Common numerators. If there's the same amount of each of those pieces, we need to look at the size of those pieces. And 7ths are bigger than 8ths because my whole is divided into less number of pieces. So we say, okay, we're going to compare 3/8 and 3/7. 3/7 is greater than 3/8 because 7ths are greater than 8ths. And we have the same number of each. So when I add on 3/7 to 5/8, I will be bigger than 1, okay, greater than 1. Okay, here's the second example. 1 2/3, subtract 5/6. Is this difference greater than 1 or less than 1? Okay, for time's sake, we'll have to just kind of go through it. Since this is 1 2/3, I need to compare my 2/3 and 5/6. So 2/3 is equal to 4/6. And 4/6 is less than 5/6. So because 5/6 is less, 4/6 is less than 5/6, when I subtract off my 5/6, that will bring me back past 1 on the number line. Okay, so maybe I should draw a number line. Here's another idea that you guys can try with these ones. Okay, draw a longer one. Oops. No, that's not good. Okay. So we have here is 1. This one is 1 2/3. It's almost a 2. Let's pretend it's right here. Or 1 4/6. That's the same spot. If I subtract 5/6, so I'm starting here and I'm going 5/6 back. Okay, that's going to be put me past 1 on the number line. So I'm subtracting 5/6. Okay. So if I subtract 5/6, I go past 1. So my difference is less than 1. So you can use reasoning with fractions. You can use a picture. Okay. And it actually gave me down to 5, 6 here. Okay. Okay. Now here's one more. 6/11 plus 8/15. You can look at the fractions and reason about their size. Both of these fractions are greater than 1/2. Okay? Which means that their sum must be bigger than 1. Okay, so there's another idea there that you can have. The last part of the lesson goes through subtraction with bar models and word problems, which you can take a look at the lesson notes for a couple of examples. We've done it before. I've showed you in the beginning how subtraction works with bar models. So you can do it, you can use that. The subtraction essentially is like where you have one bar represent one number, one bar represent the smaller number, okay? And then this is the difference. So we've actually run out of time, but I think you guys should be good for homework now. So if anybody has any questions, I can stay on for a few minutes. But you can look at lesson plans for others.
Dr. B, I had a question about the, in my grade book, it has like a little paper symbol next to what I turned in. Do you know why that is?
Okay, so let me go ahead and stop the recording.